Welcome friends to my channel. Today I am going to start a new course on Arduino. Here we are going to learn how to use Arduino board to make different small projects, how to interface different sensors, actuators, different input output device with the Arduino. Here we will start from the scratch level. To learn this project, learn this course, you need not to have some prerequisite. A beginner, those do not have any knowledge of electronics, also they can start the project. So let's start the course. When you say about the Arduino, the first board comes to our mind, that is called Arduino Uno. Because this is the most popular Arduino hardware platform that can be used to make small projects. But in addition to that, there are several hardware development boards are available. So I wanted to give you some of the introduction of the particular boards before starting the course. These are the few version of Arduino boards available with me. So first, this is the Arduino Uno. You know, this is the most popular board in the Arduino series because of this cost and its flexibility. The next board comes is the Arduino Mega. The main advantage of this particular board is that it has 54 input output lines. That means you can interface 54 input or output device with this. So if you are making a project which like a robotics, it is very useful. Then I go to the another board that is called Arduino Duo. This Arduino Duo, the advantage of this is that it has high processing speed and it uses ARM 32-bit microcontroller. This Arduino Uno and Mega, this all are using 8-bit microcontroller, but this Arduino Duo is using the 32-bit microcontrollers. After this, so its processing speed is very high. After this, we go to this board. This is nothing but the Arduino Mega R3. It is the main advantage is that it has a feature of R3 and also it has inbuilt Wi-Fi. So you need not to use or add any extra Wi-Fi when you use a project. Arduino also provides some shield with the Arduino boards. This shield is useful to connect directly on the Arduino boards without increasing any hardware connection. For example, this is the motor driver shield for the Arduino Uno. By connecting directly this board or the shield to the board, what you can do, we can control 2 servo motors, 2 stepper motors and 4 DC motors. So if you are making a project like robots, then if you use these boards, it will be very easy for you to make a robot using this Arduino Uno, such that you have different type of shield available, which I will explain in the later classes. So this Arduino Uno is the most and basic popular and easy to use boards. We will start project using these Arduino boards. So the first step to work with this, to install the Arduino IDE in your laptop or computers for the project. Let's start how to download and install the Arduino IDE in the laptop or computer. So you can start writing the programs for the Arduino. Hello friends, to download and install the Arduino IDE, we need to go to the Google and we need to simply type Arduino. And when you enter the Arduino, the first link what you get, that arduino.cc, we have to click on this home page. Once you enter to the home page, then we need to go to the software. Now in the software part, here you can see in the button you have some options like Windows 10 and newer version 64-bit installer, MSI installer. You can also download the zip file, so later you can install. Also it provides the package for Linux systems also, and as well as if we have the Mac OS, for that also it provides the IDE platform. Though here we will install for the download for the Windows operating system, so I click here. So once you click here, they will be asking for some contribution. You can just skip it and you can just click on just download. Once you click it, you can see left hand side, the download is already started. You can see here left hand side corner, download already started. It is near about 157 megabytes. Depending upon the internet speed, it will take some time. Now the installation is completed, sorry, download is completed. So now you can click here. So to start the installation process. So it is now starting the execution installation process. So it will ask for to run, and we have to agree some agreements. We have to click on next. Then again you will be asked to give some installation destinations. Here you can customize your installation destinations, but here I am not changing anything. So it will install. So again installation will take some time, near about 1 minute, depending upon your speed of your computer. So as you can see, the installation is complete. So now we can click on the finish, and then we can start the Arduino. So this is the Arduino icon. I can start the Arduino software or Arduino IDE. So once you start, we will check the basic compilation is okay or not. For that we will run a sample program or example programs for it. So as we can get the screen here, so like that you can go to the file and you go to the example. An example, you can go some basic program like blink programs, we can go. So now here you have two options. This right option is the verify option, and this right arrow option is the upload option. Though here we have not connected any Arduino physical board, so we cannot upload here, so we can only verify. Once you click on verify, so it's in the below, you can see it is showing compiling the sketch, and also in the window, button window, you will get some information about the compiling. So when it compiles, you will get some informations such as memory utilization, other things. So now it's about to complete. So see, it shows that 924 bytes it's completed, near about 2% of total memory have been consumed, and some other details also there. So this is all about how to download and install the Arduino. Now the Arduino is ready to use with the Arduino boards. After installation of Arduino IDE, next step is the power up the Arduino model. You can power up the Arduino in a two way. The first and the foremost important or easy way using a USB connector. So this end of the USB will go to the laptop or desktop of your computer, and this end will go to the directly to the Arduino boards. Once we power up the new board, you can see the LED is blinking. It shows that some program is already running inside the board. So by powering up this way is another advantage, that this same cable can be used to power up as well as to dump or write the program into the microcontroller from the laptop or desktop. So now second way is that use the DC socket. This is a 12 volt socket. You can provide 7 volt to 12 volt DC power supply, and it can be inserted directly to the power jack like that. This is required only when you have to drive a high current device, like if you have to drive a motor from the Arduino boards, then this USB cannot provide you that sufficient power, so that time you may have to provide this power supply. So after understanding the power supply requirement, now we will write our first Arduino program on the Arduino Uno, and the first program will be blinking a LED. So the first we click on the Arduino icon and the app will open. App is open now. This USB cable now we will connect to the Arduino. This port will go to the laptop or desktop USB port. So I have connected that particular laptop USB port, and this will go to the Arduino. Once you connect, you can see there will be a power on light, and though some program is already written here inside, so LED is blinking. So next step is that we have to write a program for the Arduino. My suggestion is that at the beginning you use some example programs. Arduino provides lots of example programs that you can find just going to file, example, and the basic, and then we go for the blink. So when you go to the blink program, this program will be available in the output. Now here you can see, though the program is blinking a LED, first we need to decide where shall I connect the LED. As you can see here, I have one LED in my hand. So this LED has two legs. The longer leg is the anode or positive, and the shorter leg is the cathode or negative. So this is the LED. We will understand how to interface this LED. There are several input output lines in the Arduino boards. We will make pin number 13 as the particular output pin. So in 13 we will connect the LED. So what we will do, we will make pin number 13. Here I have to make pin number 13 as a output because it is sending data outside, so I have to make it output. Otherwise I could, if I accepting the data, then I have to write here input. So though I am sending the data outside, I have made the pin number 13 output, and here also we have to write pin number 13 and 13. So what does it program does do? Actually, first it will make high pin number 13. That means in pin number 13 you will be having a logic 1 plus 5 volt, and it will stay for delay 1000. 1000 means 1000 millisecond of delay, 1 second of delay. So it will glow for 1 second. Then we are making pin number 13 as low or 0 volt. Again it will stay for the 1000. So though this program is already running, so let's do some changes and see the effect. So what I do, instead of 1000 I make it 100. I make the time delay equal to 100 and 100. And now how to burn the program into the Arduino we will learn. At the top you can see there are two signs. One is the right sign, is the arrow sign. Right sign is to verify the program whether there is any syntax error or not. When you click here, you can see it is compiling the sketch, and it will show whether is there any error or not. And this right arrow is to build the program inside the chip. So when you click it here, the program will be burned inside the microcontroller chip. So as you can see, it is successfully verified. Now I will burn the program inside the chip. You can see the activity while I am burning the chip. So I have click on this build function. Now it is showing some error. Why this error? Because I have not selected the ports. You have to select the port where you have connected the Arduino. So for that you need to go to the tools, then you have to go to the ports, and you have to select the particular port where the Arduino is connected. Here COM55 is connected, so I have to select it. And another work you have to do, that is that you have to select the which board you are using. So though you are using the Arduino Uno is already selected, so no problem. So now we can again start to build the program or burn the program in the chip. Now let's see what happens. You can see the activity going on in here. Now it is showing uploading and down uploading. Now see the blinking speed have been changed from 1000 millisecond to 100 milliseconds. So this is the first program how you will verify your boards and your program. Now we are going to connect the LED with the boards, as we have specified pin number 13 as the output ports. So you can see this is the pin number 13 and the next is the ground. So anode should go to the pin number 13 and cathode should go to the ground terminal. So we connect it. This is the pin number 13. and this is the ground. We have connected the LED in a 13 and ground. Now you just power up, this LED should blink. As you can see, it is blinking. So this is the first program you need to learn, but we need to understand the every feature of this particular boards, that how many pins are there, which are the functionality of the particular pins, what are the things we can do with these pins. For that, the next video will be explained. What you can see in the screen is nothing but the pictorial view of the Arduino board. It is the same structure of the Arduino board what you have practically. So now here I am going to explain the various pin details of the particular Arduino. Here you can see all the pins are matching with the diagram. So instead of this, now I am showing in the screen. So actually in Arduino Uno you have the 14 input output lines, that is called digital input output lines, starting from this 0, starting from this pin and end with this particular pin number 13. This whole entire pins, there are total 14 input output lines. So these 14 input output lines can be used as a input or output lines, but it can only accept digital input output. In addition to that, there are 6 pins. These are the 6 pins which can be used as a PWM output. PWM stands for pulse width modulation outputs. Later I will explain it, but for now time being, just to understand, this can be used to interface servo motors to the Arduino Uno. And here you have the A0 to A5, total 6 analog input. These are called analog input pins. These pins are used to interface basically the sensors with the Arduino, because the output of the sensors are basically analog in nature. To receive the data, you have used this Arduino A0 to A5 pins are available, because inside the Arduino there is a 10-bit ADC. ADC stands for analog to digital converter. There are 10-bit ADC are available which converts this analog to digital. Here you have basically the power pins. Here you can have plus 5 volt, you can give plus 5 volt here also, or you can take this 5 volt for some external circuit also. Suppose there is some extra circuit are there, some sensor there which require plus 5 volt, so you can take from here to give the supply. Then some of the sensors and devices operates in a 3.3 volts. In the boards also provides you 3.3 volts, so that if you have any external device, input output device which require 3.3 volt, it can provide you the 3.3 volt power supply for the particular device. This is the reset pin. When you give a logic 1 to this particular pin, the microcontroller will be reset. And here you can see there is a particular pin, is called V in. So this V in is nothing but this pin only. So you can insert external input voltage that you can vary from 7 to 12 volt. So you can apply 7 to 12 unregulated input voltage at particular V in page. So what will happen? The microcontroller will get a regulated plus 5 volt. Next pin is the IOREF, that is called input output reference voltage. This is required when you are connecting various shield. I am not going to explain you now, later I will explain. And another pin is there, that is called AREF. AREF stands for analog reference voltage. The ADC what you are using inside the microcontroller, it needs some reference voltage. So this pin we can provide the reference voltage for the ADC. In addition to that, we have some extra functions like SDA and SCL. This is basically used to interface the I2 devices or I2C devices. That will also explain later while interfacing the sensor incorporating the I2C protocols. So this is the basic structure of the input output pins. So in summarized view, you have 14 input output digital lines from where you can send data outside or you can accept data inside digitally. You have 6 analog pins from A0 to A5 from which we can accept the analog input basically from the sensors. Also you can have a 5 volt and 3 volt 3.3 volt power supply also that can be fed to the external power supply or external devices. In addition to that, you have a REF also, reset pin also, and SDA and SCA to interface the I2C. This is the USB port. Already I told you that this will be used for powering up the Arduino board as well as to program the Arduino boards, and this is the external DC power socket where you can provide again 7 to 12 unregulated voltage so that the board can be regulated. And this is the particular regulator IC. These are the two regulator IC which makes 5 volt regulated output and 3.3 volt regulated output. So this IC is responsible for making this input voltage to 5 volt regulated output, and this IC is responsible to making this input voltage to 3.3 volt regulated output. This is the bootloader IC. This is also a microcontroller, but I don't want to go in depth in this now in this time, but later I will explain. And these are the some LED or indicator. This is the TX and RX indicator LED. Whenever you are transmitting something through this TX line, then this LED will blink, and same way when you are receiving some data from this RX line, that time this LED will blink. And this is the one LED has been provided in the board which is connected to by default pin number 13. That's why when you ran the blink program, this LED was blinking. So just let me show this once again. You can see that this LED is blinking. It is nothing but that particular that you can see the LED is blinking. This is nothing but particular this LED. So this is given for testing purpose. You have the another part that is called ISCP, in circuit serial programming, that will explain you again later. Now I don't want to explain that ICSP, so in circuit serial programming, by which you can program. That is different programming technique we will learn in the later part of the course of this. So basically I think the idea about the Arduino is okay to everybody. So hope you have enjoyed the video. Thank you for watching. The most important part we have to consider now, that is called this. This is the microcontroller which have been used in the Arduino Uno. This is the Atmega 328P. The P stands for picowatt because it consumes picowatt power. This is a basically 8-bit microcontroller having 32 kilobyte program memory. 32 kilobyte program memory in the sense you can write a program up to 32 kilobyte of size. So this is the advantages. Then it has a RAM also, 2 kilobyte SRAM inside the microcontroller, and it also have EEPROM, that is electrical erasable programmable read-only memory, that size is 1 KB. So your program memory is 32 kilobyte, RAM is 2 kilobyte and EEPROM is 1 kilobyte. This microcontroller can be operated from 1.8 volt to 5.5 volt, but you cannot have highest clock frequency at lowest voltage level. Basically in this board they have given a crystal. You can see this is a crystal oscillator which is nothing but a 16 megahertz crystal has been given. So at 16 megahertz crystal has been given in the board, though it is using in a plus 5 volt supply. So I think we have some idea regarding the pin details of the Arduino and other features. So hope you have enjoyed the video. Thank you for watching.